Hello everyone. So today we want to talk about this code, basically this problem, binary tree with factors. So let us read the description. So given an array of unique integer array, where each integer array of I is strictly greater than 1. Okay. We make a binary tree using this integer, and each integer may be faced for a number of times, any number of times. Each non-leaf node's value should be equal to the product of the values of its children. Okay, return the number of binary trees you can we can make. The answer may be too large, so the answer so return the answer by taking the model of 10 to the power 9 plus 7. Okay, so for example, the array is given as 2 4. Now what are all the binary tree possible? So it can be one is 2 itself, and another is 4, then another is 4 2 2. Now you can see we are representing the tree form to show that this 2, when you multiply by 2 into 2, we are going to get 4. So basically we need to do like that. Okay, so here three ways are possible for that. Now when we are going to talk about this problem, this example 2 4 5 10, you can say how many are possible. First we'll be taking individually 4 5 and 10, so this gives us 4. Okay, now again we are going to talk about 5. 5 is not possible, so we have to talk about 10. So here it is 5 and 2. Okay, now 4 we are going to take 2 and 2, so this is 5. uh, for this 10 we are going to get another also, that is 2 and 5. Okay, and this is 4. This is basically the root, and these are the children's. This is the root, this is children, this is the root, this is children. So how many trees are possible? 1 2 3 4 5 6 7. So we are returning 7 here. Okay, 7 is the output here. So let us talk about the constraints. Constraints of array dot length can be about 1000, and array of I is up to max of 10 to the power 9. Okay, and it starts from 2. Okay, so let us discuss the code here. So let me take an example in this case. So the example we are going to see. Let me copy that from above. So that 2 4 5 10. Okay, 2 4 5 and 10. Okay, so 2 4 5 and 10, and we are calling that as array. Okay, so we are calling this A, and indices are 0 1 2 and 3. Okay, so first step is basically we are sorting that. Okay, so it is already sorted, so no need to make changes. Now first step is we are making a map. Okay, we are making an unordered map. Okay, so that we can easily access those elements. Okay, so and we are calling that map as MP. And in this, what we are going to store, we are going to store this AI values. Okay, so MP of AI, this is key and this is value. So AI is this values, so this values will be stored in the place of key, and in the place of values we are going to store this indices. So basically 0 will be with, 2 will be with 0, and 4 will be with 1, 5 will be with 2, and 10 will be with 3. So this is the first step. Okay, now in the next step, what we are going to do, we are going to make a DP vector of type long, and we are going to set them to 1 initially. So suppose this is DP, and the size will be obviously 4 1 2 3 and 4, and initially all will be 1 here. Okay, this is done. Now we are going to talk about this loop, what in this loop is happening. So we are going to use two iterators. The first is I, and then another is j. So first I, it will be starting from I equal to 1, and j will be from 0 to less than I. Okay, not equal to I, it will be less than I. So for I equal to 1, in this we are just checking this aij value. So in this we are iterating. So initially our I will be at this position, and our j will be at this position. Okay, so for the first case, now we are going to check this condition. If ai, which is nothing but, in this case it is 4, when you take modulus with aj, which is nothing but 2, you are getting 0. Yes, this condition is satisfying, and you can see this condition is also satisfying. So mp dot find ai divided by aj. Ai is nothing but 4 divided by 2, nothing but 2, and you can see, you can easily find that mp dot find. So you can find this 2 here as a key. So this will be returning true, and then we are going to enter this, and we are going to update this dp values. So initially it is 0, 1, 2 and 3, and then dp of I. Okay, so dp of I is nothing but dp of 1. dp of 1 is the will be changed. So dp of 1, what how it going to change? So basically we are first going to find the value from here. So dp ai divided by aj. So ai is nothing but 4 divided by 2, which gives us 2, and dp of basically from here you can see we are going to find the map value for 2. Okay, so map value for 2 is 0, and dp of 0 will be multiplied with the dp of j. So dp j value is nothing but 0, so it will multiply with the dp of 0. Okay, so when you multiply both of them, you will be getting the value as 1, and we are going to set that value here. So we are going to just add that value dp of I. dp of I is nothing but 1, so this 1 will be added to this one, so it get the value 2. Okay, now for the next cases you're going to see we are going to move our I position, because j condition will be not satisfying for the next values. So we are going to move to the 2 here. Okay, but you can see for the 2 it will not be satisfied for any other values. For 2 also it will not be satisfied, 4 also will not be satisfied. Then we are going to move with the value I equal to 3. So we are going to talk about this I equal to 3. Now we have j value from 0, 1 and 2. We have 3 values. So first values will be for 2. So you can see for the first it will be satisfying, because when you take 10 modulus 2, it will be satisfying this condition. And you can see mp dot find 10 divided by 2, which is nothing but 5, and you can easily find that 5 here. Okay, so this condition is satisfied. So we are going to move in this. Now we are going to see, we are going to change the value of dp of I. I is nothing but 3. So this value will be changed. So this value is nothing but dp of 3 plus this value will be dp of j is nothing but dp of 0, and dp of 0 is nothing but 1. So 1 will be multiplied with dp of ai divided by aj. ai divided by aj is nothing but 10 divided by mp of 10 divided by 2, which is nothing but 5, and for the mp of 5 is nothing but, you can see it is 2, and dp of 2 is nothing but 1. Okay, and 1 will be multiplied with the 1. So we are going to get dp of 3 is nothing but 1, and 1 plus 1 we are going to get 2. Okay, so dp of 3 will be changed as 2 here. Okay, now for this you can see for the next value it will not be satisfying. Okay, but for this you can say it is again satisfying the condition. So for this we are going to see the value what will be happening. So ai is nothing but 10 in this case. So 10 modulus this condition will satisfy, this condition also satisfied. Now for this we are going to again change the value of dp of 3. So dp of 3 becomes dp of 3 plus dp of j is nothing but dp of 2. Okay, dp of 2 will be multiplied with the mp of ai by aj. ai is nothing but 10, aj is 5, so we'll be getting 2, and mp of 2 is nothing but 0, and dp of 0 is nothing but 1. Okay, so 1 will be multiplied with the 1, or dp of j is nothing but dp of 2, and dp of 2 is nothing but 1, so 1 will be multiplied with the 1, and it will be nothing but 1 only, and here it is 1, and we are going to add that value to the dp of 3. So already dp3 is 2, and we are going to add the value 1 here. Okay, so it becomes 3 here. So what are the values are there in this? So 1 plus 2, okay, plus 1 plus 3. So what will be a value? Value will be 7. So here we are just finding the sum of all these values, and we are taking the modulus so that it doesn't go over to the 10 to the power 9 plus 7. Okay, so that is for this video. I hope you got the basic idea of the code. We'll meet in the next video with another such problems.